Okay. Okay. Thank you for coming to listen to TerraPower's presentation this evening. We really appreciate you making the time. And going to talk a little bit about TerraPower and our Natrium technology in the time we have today. So first, let me start by saying that Bill Gates, our chairman and founder, created TerraPower back in 2008 to solve some of the world's toughest challenges. And that would include climate change, energy security, energy poverty, and global health. And so what we're trying to do is bring to the market a technology that can be on the grid of today and the grid of tomorrow, which is dynamic and evolving before our eyes. When you think about electrification of vehicles and industrial processes, and you think about data center demand and just the power increases in the developing world and the need for clean baseload power. And so what we're trying to do is bring a dynamic and flexible product to the market. And so we think that product has to be a low pressure system that is a simple architecture, that is safer to operate and easier to maintain. That is the fundamental essence of TerraPower's Natrium technology. And we think that if we can bring such a technology to market, we can scale it not only in the United States but globally, and we can provide a new solution for the market based on our architecture that is different from today's reactors, which are larger structures that have a tremendous amount of nuclear safety equipment and piping, and also need a significant amount of water and labor to build and also to maintain. And so whereas we are using a much lower quantities of labor and nuclear safety grade quantities with a much faster construction schedule for a lower capex and a plan to standardize our reactor in the United States and globally as we incrementally retire risk in our program. And so when we talk about innovation in nuclear, what we have done is created a technology for the market that has borrowed the energy storage concept from the concentrating solar industry and merged it with our nuclear for an energy plus storage nuclear solution. So this is the only energy plus storage solution on the market or coming to the market today, and no other technology on the market or coming to the market, whether it's a Generation 3 Plus or Generation 4 technology, has our architecture. And so what we're bringing to the market in the base case is a 345 megawatt electric Generation 4 liquid metal, sodium-cooled, fast reactor with built-in energy storage. And we can ramp our power up to 500 megawatts for 5.5 hours. So what do I mean by that? I mean, we can discharge our power system like a giant battery for 5.5 hours. We can recharge it several times a day, which is a completely different use case from grid-scale batteries, and we do not have the critical materials risk. But we can also ramp power very quickly at 10% a minute to provide smoothing of the variability on the grid, which is encumbered with renewables, and also susceptible to storms and other natural disasters due to climate change impacts. And so we also have a resiliency benefit as well. And we do not require power to cool our reactor. That's another important point. That is a difference between our systems and others that are on or coming to the market. Passive cooling is the system that the U.S. Nuclear Regulatory Commission cares about when it comes to our safety case. And the other thing about us that's important is we have a very small emergency planning zone, which is 400 square meters, in fact. And that allows us to site our reactor closer to population centers and also to industrial facilities, which is going to be a major benefit for us as we move forward with our scaling program in the 2030s. And on top of that, from the water use perspective, we are using significantly less water than current reactor technologies and others coming to market. And there's probably two key reasons for that. The first is we're not using water to cool our reactor. That's point number one. And point number two is that we have flexibility in terms of our water usage for steam production on the turbine side. And in water-stressed areas of the United States, such as, for example, Utah and other places, we can provide significantly less water usage scenarios that are very attractive for those areas. And because we are a low-pressure system with very comparatively smaller nuclear safety quantities in terms of concrete and steel, we also have a much lower capex, which is very important, and a faster construction cycle. And these are benefits that we have modeled internally from the economic standpoint, and we've also outsourced some of the economic modeling, and it's been validated actually in some of the IRPs, integrated resource reports from U.S. utilities, including the 2024 TVA IRP, which showed our reactor, the Natrium technology, as the lowest cost reactor in their system compared with other technologies, including larger and smaller Generation 3 plus light water reactors. So our design strategy is a key element for commercialization of Natrium. What is that? I mean, if you look at the dotted line on the screen, you can see that we have two sides of our plant, the nuclear island and the energy island. And the nuclear island is regulated in the United States by the U.S. Nuclear Regulatory Commission. And so that is where we are in the process of receiving our construction permit, our permission to pour nuclear concrete, in other words, right now. But the energy island, where we produce power, steam, and heat, and where our thermal energy storage system that we borrowed from the concentrating solar industry resides, is not regulated by the NRC at all. So what does that mean for us? That means we are regulatorily and operationally decoupled. That's what the dotted line represents. And that gives us a number of benefits. Perhaps most importantly is that the nuclear island and the energy island can be operated independently. And that is actually a part of our architecture that no other company bringing it to market has. And on top of that, grid operators and RTOs can actually control our turbines, which is another first in our nuclear industry. And on top of that, because our energy island is not regulated by the Nuclear Regulatory Commission, we do not have to use nuclear grade materials on that side of our plant. Everything is commercial off the shelf, which results in significantly less nuclear quantities overall in our plant, 40% less, and also other benefits as well. And we are an equipment-focused reactor, which means our labor is comparatively less, and our construction schedule is comparatively shorter. In fact, in the nth of a kind configuration, we are targeting 36 months or less for our overall construction from first nuclear concrete to fuel load. Now, some of us in our company talk about getting busy with building reactors. Stop talking and start building is exactly what we say in point of fact. And that is exactly what we are doing with our first project in Kemmerer, Wyoming, which is part of the U.S. Department of Energy's Advanced Reactor Demonstration Program. And that is an award that we won in 2020 in a competitive landscape against other reactor technologies. And so right now, we're finalizing our design, and I'll show you a picture of our commercial architecture in a few minutes. And we are using the 10 CFR Part 50 process in the United States, which means we are using a two-step process, which means we will file for permission to pour nuclear concrete first. We've done that already. In fact, we filed that. That's called the construction permit application in 2024 in the spring. And then we will get our operating permit second, as a second step in the process, and we'll be working on that filing in 2027. And along the way, we've had a number of regulatory successes that I'd like to highlight. I mean, first, we have put a significant amount of time into our relationship with the U.S. Nuclear Regulatory Commission, and that had resulted in us being accelerated even before the current president, Donald Trump, put out a number of executive orders aimed at accelerating our industry. And since those executive orders have come out, we've been accelerated much more to the point where we expect to get our permission to pour nuclear concrete this winter, the winter of 2025. And even before that, we had received our industrial state siting permit from Wyoming, where we're building our first reactor. And that is actually a first for the nuclear industry, that an advanced generation reactor like ours got a permit to proceed with non-nuclear construction in a state in the United States. And so we are proceeding, in fact, with non-nuclear construction right now. And on top of that, and I think we'll talk about our supply chain in a couple of minutes, but we have been very, very busy on the supply chain side and have awarded all of the major components for our nuclear island. And in fact, we are placing long leads and we're moving to fabrication for a number of those parts. And some of these pictures on the site you can see from our groundbreaking ceremony in 2024, which was our original groundbreaking at the site. And one of our partnerships with our Korean colleagues, HD Hyundai, a key supply chain partner. And then some pictures of our test and fill facility, which is key for our key for our technology de-risking that we're building on site right now, where we're going to test in sodium most of our components, prototype and full scope, before they go in to the reactor. And of course, we have built our system from the ground up with 3D modeling, and that helps us understand our costs and be able to talk to customers about true costs for first of a kind and nth of a kind as we go through our program. So I mentioned supply chain a minute ago, and I'd like to highlight our supplier map. I think I should take a moment to recognize Framatome and Orano, if they're here, and ArcelorMittal, one of our investors and upstream partners for fabrications, because we do attach priority to the French supply chain. And we can see from this conference here how deep the supply chain is in this country. But you could also see that we have a multinational supply chain that spans Korea and Canada, of course, the United States, the United Kingdom as well, and Spain. And so you can see some of the different components that we're highlighting here, including in the United States, Curtiss-Wright, with our reactor protection system and our distributed control system, and of course our training simulator. And since we're in France, I'll highlight Orano, both the U.S. and the French entity, for some of the cooperation that we're having with them. So again, as I mentioned, we have awarded virtually all of our major nuclear island components, and we're in fabrication and long leads on a number of them right now, all pointed toward fuel loading in Wyoming in 2030 and full power on the grid in 2031. I mentioned our commercial configuration earlier in my talk. I think it's worth noting that in Wyoming, we're building one 345 megawatt electric baseload nuclear power plant and the energy island with a 500 megawatt electric turbine, which again, we can ramp power from our energy island at 10% per minute. However, in our commercialization, we are a dual unit reactor. So you can see our nuclear island and energy island with our regulatory and operational decoupling that I highlighted earlier. as well as the two reactor units within the orange box there, which represents roughly 700 megawatts electric of base power. And then you can see our energy storage tanks in the middle that I mentioned we borrowed from the concentrated solar and our power, steam, and heat production to the left of that. And so in the base case for commercial, it's roughly 700 megawatt electric base and a gigawatt at the turbine. But probably another most important point to highlight is that we can actually have a lot of flexibility on the energy island side because it's not regulated by the Nuclear Regulatory Commission. So if one of our customers wanted a different configuration, such as more tanks, such as smaller or larger turbines, or another configuration, we do not have to go back to our regulator to get permission to make those changes on the energy island side, which is completely different from other reactor technologies and their architectures on or coming to the market. So I think this is actually my last slide, and I should start where I should end where I finished, which is we're not talking, we're building. This is a picture of Wyoming as I test our test and fill facility. This is a very recent picture of metal going up on site from Kemmerer. And so in this connection, we're maintaining and developing some very strong partnerships in the local community. We're actually replacing a coal plant. It's converting to gas, but eventually will go offline. Okay, got you. Okay, thank you. Yeah, it's that will eventually go offline, and there's a coal mine that is going to shut down as well. So part of our partnership in this region of the United States is the helping with the economic dislocation caused by the shutting down of these plants, as well as enabling local businesses in the local communities in terms of economic development and participation on the site. Of course, we also have EPC relationships on the site with Bechtel Power Corporation, which is another strong partnership we have, in addition to the supply chain that I mentioned. And we're building our first unit with scalability in mind. So we're going to standardize our technology and be able to roll it out consistently throughout the United States and then in international markets. And we can use our NRC licensing process as leverage when we enter other international markets as well, such as, for example, the United Kingdom, where we announced our intention to enter the GDA process there last week. And we also are leveraging advanced modeling to reduce risk. And this is something that we've been doing since the early days of our program. And we have a very robust delivery organization that is pointed toward an on-time deployment, not only for Kemmerer, but for future units. And in Kemmerer, we estimate around 38 months from fuel loading to construction. And as I mentioned, for our nth of a kind, we estimate 36 months from fuel loading, from first nuclear concrete to fuel loading. And so with our partners, we're working very hard to maintain our schedule in Kemmerer and to provide confidence to the market that we can maintain our schedule as we move forward with our commercial program. And so that is what I have today. I think I finished 5 minutes early, so if there's any questions, I'm more than happy to answer. But otherwise, I thank you for your time and for your interest in TerraPower.
Yes. One question?
Oh, yeah. Hi. TerraPower just submitted an application in the UK for the Natrium. But you don't have, as far as I can tell, an actual customer there. What's the sort of plan in the UK deployment?
Well, I'd like to highlight a couple of things in that respect. The first is our delivery partner, KBR, who's sitting in the front row right here, Paul Pearson. So our intention in the United Kingdom is to partner with KBR and enter the market. And we will be looking for hyperscaler partners from the United States to join us in building AI data center parks in the United Kingdom. So, you know, in connection with entering the market, there are many things in process that will become more crystallized over time. Mm-hmm.
One more?
Is this a modular constructed nuclear reactor? Meaning, is it made in a factory and shipped the components to the site, or all stick built on the site?
We will modularize as much as possible, probably more on the energy island than in the nuclear island. We'll have integration facilities on site in order to bring the nuclear island together, and in particular the reactor enclosure system, which houses our reactor vessel and the fuel. So it's going to be a combination of modular and stick-built, in short, to answer your question.
The unique aspect of a nuclear island and an energy island seems like it would be tailor-made to have a bridge power solution also on the site to provide backup power in a fossil fuel application.
That's a good point, and it's something that we're looking at because, as I mentioned, we're 2031 for full power in Wyoming, and we understand that our hyperscaler partners, for example, would like power sooner than that. So we are looking at bridging approaches. Absolutely.
Well, we still have time. Last year, Rocky Mountain Power, which is the potential counterparty in Kemmerer, they had previously talked about 4 natriums. They then had resource planning come out just talking about 2 and keeping coal plants open longer. Do you hope or predict that new resource planning will see them increase their potential order?
You are very well informed. No, what we've done so far is negotiated and put in place a PPA with Pacific Corp, Rocky Mountain Power, which is a regulated, entity, as you know. And then we're in the process of discussing larger plans with them at this moment.
One more.
Thank you for your presentation. First of all, it was really very interesting. The question regarding the fuel, as far as I know, Natrium will need the HALO fuel, and probably you can give us a bit more information on the amount of the fuel available today for the first demonstration unit, sure, and the fuel needed for further commercial deployment of the reactors. Thank you.
Mm-hmm. First of all, I neglected to talk about fuel on the supply chain side, which in hindsight was a mistake. So let me address that now. It's difficult to get into specific quantities, as you could imagine, for first cores and reloads. Of course, we do have such information that we discuss with our partners. But what I can say is one of the biggest misconceptions I think about TerraPower and Natrium is that we don't have fuel. That is a comment that is out there in the market. I want to dispel that notion right now and let you know that for our first unit in Wyoming, we absolutely have fuel. We have 3 legs to our stool, so to speak, our fuel stool, which is enrichment, metallization, and fabrication. And for enrichment, we are working for the first unit in Wyoming with ASP Isotopes, which is a company that will deliver our HALO product in 2028. And for metallization, we're working with Framatome. And by the way, we put out a press release yesterday with Framatome showing that they successfully metallized uranium pointed toward our plants, which was a major accomplishment and a significant fuel de-risking activity. And that's on our website and on Framatome's website right now. And the third leg of our stool, fuel fabrication, is being done by GNF, Global Nuclear Fuels in Wilmington, North Carolina. All of those are proceeding in execution mode toward 2028 startup for delivering our first core in Wyoming.